Good evening. My name is Yahoo Ortiz, and this is my constant velocity lab. So, some introductions. The purpose of this lab was to compare an object's predicted position against its observed position. And we did this by recording a video of us rolling an object across a platform and then putting that video into a tracker, which would give us our observed position and velocity. And then we put in some data into GlowScript, and now gave us our object's predicted position and velocity. And we did this in order to demonstrate Newton's second law. Okay, Newton's second law. Famously, force equals mass times acceleration, interpreted as net force equals momentum over change in time, which can be further interpreted as momentum equals net force times change in time. Further interpreted as final momentum equals initial momentum plus net force times change in time. Further interpreted as mass times final velocity equals mass times initial velocity plus net force times change in time, which would give us our velocity update formula of final velocity equals initial velocity plus net force over mass times change in time. And here's my tracker video. For my video, I use a 500 milliliter water bottle, which gave me a weight of 500 grams. And for the calibration, I used a stick of the order, which was about 6 inches. So some analysis. As you can tell from the slope, we had a constant velocity like close to it. And in order to determine the velocity, I calculated the change in position, final position minus initial position over change in time, 3.167 seconds. And I got a velocity of 0.5460 meters per second. And for my position, I just got it from this. So some computational. For delta, I just used the first number of frame, which was 0.033. And for ball velocity, although we do need to put the velocity update formula, which had net force over mass, because net force was 0, I just didn't include it, so I only had the initial velocity. And here's our graph for the GlowScript model. Some comparison. Our blue line is the tracker, and our orange line is the GlowScript or our computational. And although you can tell they're somewhat similar, they're not the same, and that could be for a number of reasons. There was a bump in the surface in my tracker video, which could have affected the velocity. And furthermore, the tracking application may have had some errors. Also, no accounting for the outside forces in the GlowScript model, like friction. So that may have affected the velocity. What if we flip the axis? Well, the only thing that would happen was we get a negative slope. And what does it mean? In our computational model, the net force was set to 0 because the ball moved with like constant velocity. But a net force of 0 does not mean that no forces were acting on the object. We're acting on an object after the push. The water bottle was still being pulled down by gravity and pulled up by the surface. These forces were approximately equal in magnitude, but in the opposite direction. So added together, they give us a net force of 0. Therefore, at least 2 forces were acting on the ball, even though the net force was 0. And that'll be all. Thank you.